In this case, in today's class, we'll discuss about the implementation of digital twin for real-time scenario. So just discuss up till now what is digital twins. So it's digital twin is nothing but integrations of actual uh, physical system. Okay, with the help of different components, computational components, and we are analyzing this behavior, okay, of that particular systems based on the data, and we can predict the different activities. We can predict the performance of the system based on this digital twin part. Okay, now just look at this flow. So what we have these different examples of digital twin for smart manufacturing, this digital twin for product designing, for manufacturing process, for different people's for different networks. We are using this digital twin to reduce the human efforts and to improve the overall efficiency. Now this system, how that system is integrated to each other, that is important. So what we have information of product, we have information of machines. Okay. So first we need to take the actual work environment scenario. We need to we need to fix that part. We need to add that part of working environment into the systems. And based on this part, we can check the uh, performance. We can check the system performance, and then we can take the decision for optimizing the overall workflow or to enhance the machine performance or to analyze the machine actual working health conditions whether the system is performing as per the standard or not. Okay, so this is the physical world. We are integrating with cyberspace means physicals. We have physical world means we need to develop or design the product. We need to manufacture the product by using machines. So to add that part, we are giving specific working conditions, work environmental conditions. We are providing some specific limitations, and based on this part, we are checking the performance of machines. Then next, uh, this is integration. First, cyberspace with physical world. Second is development of this digital twin part. Okay. So as per the requirement, we can select the we can develop appropriate machines. Okay, we can design that for particular systems for or we can select that particular system for product development. Now, what kind of mechanisms are there, that is important. Okay, like we are talking about, we need to integrate these cyber systems with physical systems. So first we should know what kind of products or what kind of components are there which we need to integrate. Like we have this field bus networks like device net is there, Profinet is there, Modbus is there. These are the networks which are using to transfer the informations. Okay. Then we have industrial networks. So whatever information is there that is collected at machine information or machine monitoring conditions will be collected. Then that information will get transferred with the help of this wireless networks. So this is again a communications protocol. We are using Bluetooth network or Zigbee network, wireless sensors we are using, and then that technology is MQTT or OPC or UPI is useful for analysis purpose. So this is the digital twinning mechanism. First, we are analyzing the actual working conditions. Then that conditions, working conditions or working parameters will be analyzed, and then that information will get transferred with the help of this communications protocol to server, and then it can detect the performance or predict the performance of product. Okay. Now just look at the flow. Now what we have the parameters related to design. So different standards are there. ISO standards are there for this uh, developing this digital framework for manufacturing sector. So you can implement this part into the systems. Okay. There are standards for planning for manufacturing, planning for inspection, planning for overall flow. So these are the overall standards. So now whatever standards are there, whether we are manufacturing or whether we are systems is developing the product as per the standards or not, again that we need to check. Okay. Now look at the flow. Just we are implementing whenever we are implementing this digital twin part for manufacturing sector, what kind of data we need to consider? So first is uh, informations of product. Okay, so what we need to, so how many equipments we are using, what kind of material we are using, what kind of processes we are performing, that we need to select. Okay, then available facility, working environment. Okay, and the technical documentation related to part. So this is all about observable manufacturing elements that we need to consider. Now look at the scene. So in digital twin, so whatever actual process flow is there for any industry that we are creating by using virtual prototype in digital twin. We are integrating this man and machines. We are integrating this equipment. We are taking into account various materials required for production part. How that protocol different processes we are performing. Okay, what kind of facilities are there for moving that components from one station to other station. then actual working environment, and finally how that product will get delivered to customer. And this is all about related to digital product supporting documents. So this part is actual real-time control. Now analysis where we can perform the analysis. So actual real-time data is taken into this part. The performance of systems will be taken into this part. Real-time control, that means we can analyze the flow where system is performing as per the requirement or not, or whether we need to increase the equipment, whether we need to change the process flow, or whether we need to change the different technicians, or whether we need to add different machines. That can be analyzed. So that is one part where real-time control is there. Okay. So different, by varying the different performing parameters, we can analyze the system. That is one thing. Second is offline analytics, means we have some historical data related to machines. We have some historical data related to products. Okay. So whenever whenever we are doing virtual analysis of that product with the help of this digital twin, we can check the uh, performance of that particular machine by varying the different parameters. Okay. So health check is nothing but we are talking about machine performance. Okay. So we can change the speed. Suppose we are checking the performance of CNC machine or VMC machine. So we can change the feed rate, we can change the speed, we can change the lubrications, we can change the depth of cut. So by varying the different parameters, we can check the performance, whether that product manufactured by that system is as per their standard or not, whether you are getting surface finish as per the requirement or not. That can be analyzed. Okay. So that will come under this health check part. And next is predictive maintenance. Okay. So under predictive maintenance, if that system, because this digital twin again we are using AI integrations, AI and ML integrations we are using. So based on this analysis, we can check the overall system performance, and we can easily analyze where that system may get failed after repetitive usages. Okay. So if when tool would, after if the tool is get suppose if there is a wear and tear of tool, or suppose if tool get failed, then at how many periods of times or how many time of operation that system may get failed. That data will get from this digital twin part. Okay. Now these are the different advantages why we are implementing this digital twin. So this part is helpful for planning and validation purpose. So in your planning and validations, we can use this digital twin for manufacturing industries. Then next, production scheduling and assurance. We can schedule the different processes. Okay, so these are the one more advantages. By changing the scheduling process, what is the impact on development of product, that can be checked. Okay, so this is again one more advantage of implementing digital twin for manufacturing sector. Then it enhance the understanding of manufacturing elements. So we are integrating different elements to each other. We can club different elements to each other. So we are getting an idea about overall performance of particular manufacturing line or manufacturing flow, shop flow. That idea will get. Okay. Then dynamic risk management. Now there is a chance where by interchanging the different man and machines, we can check the system flow. So whether we need to enhance the, suppose if you want to enhance the efficiency, if you want to enhance the overall efficiency of systems or that machines, you need to check the uh, performance of each, and you need to analyze the performance of each and every machine. Suppose if machine is not performing as per the requirement, then we can take appropriate decisions, whether we need to implement multiple machines on same stations, or we need to add different skilled persons on that particular machines to enhance the productivity. That decisions we can take. Then again, it is cost reduction. So we are with the help of this digital twin, we are planning the inventory. So the requirement raw material will come into the stations at appropriate time, and overall scheduling of that particular product can be done. So basically, from scrap to final product development, all these processes are analyzed under this digital twin part. Okay. And virtually we can simulate this part. And once this virtual simulations is giving the perfect result, then we can start the actual productions of that systems. Okay. So this is the advantage of this digital twin for manufacturing sector, why we are implementing this digital twin for manufacturing sector, and how it is helping that manufacturing sector to improve the overall field. Okay. Just it is giving an example of graphics. Here we are doing for this bicycle development. So based on the requirement, how the bicycle was developed, or how they are by using model analysis, how it is tested. Okay. So they have just given the one example here. modular industry real-time augmented graphic is designed, graphic engine is designed for this bicycle purpose. So these tools are configured in such a way that just look at the information like we have developed the model, we analyze that model, we have the sensors for analyzing the performance of that systems. Okay. Then we are configuring this part and then we can do some data acquisitions. So overall system performance of that bicycle or overall design of the bicycles can be analyzed virtually. Okay. So therefore this year we can develop this bicycle, we can check this bicycle performance by doing some simulations and validations. So this is all about how we can implement this digital twin part for manufacturing sector and how it is helping the manufacturing sector to improve the overall efficiency. Okay. So thank you all.